Today is June 6, 2018. This is Austin Powers. I'm doing my code for my Spring 2018 Capstone project. First I'm going to do something and see if it works. If it does work, then I'll explain to you what I did. So you can see in this shell right here, there's a command waiting to be executed. You know it's waiting because the cursor is blinking, and it's the last line in the shell. And I'm gonna press enter to do it. And what I think is gonna happen, but don't know, is that see those two LEDs? I expect the red one to flip on and be on for about a minute. That's what I expect to happen. I don't know what's going to happen yet, not until I press enter. My hand is over the enter button. 1, 2, and it's still the same shell and everything. Alright, and okay, so the red one came on. This is good. And so here's what I did. I'll verbally explain while you watch it until it goes off. I took an XML file, or there's an XML that basically gets instantiated with the module. When you run the module, it creates that XML as a testing XML. And I use that XML to send a command to the house object to turn on that light, which represents an actuator going forward. And notice now that on the shell screen the cursor is blinking. And here, I'm gonna try and type another line of code. Oh, no, I can't. You know why? Because it freezes while it's outputting a signal. And it's still outputting that signal. Verify. Yep, it's out. Oh, and it just went off. Okay, which is what it was supposed to do. And see, now it is the next line. I can type code. Not that that's code. But it unfroze. The screen unfroze. So those are two things that are supposed to happen. Now H.tempbird is a method from a house object. A house object is a thing that can process XMLs and turn them into actual signal commands to actually output logic signals from the Raspberry Pi. And house objects have a lot of methods, but one of the methods that they have is they're these, I call them bird methods. This one's called tempbird. There's also an instabird and I call it sketchbird. But tempbird does the XML for the temperature specifically, and I'm going to show you the information that it was just working with. So it has a list of all the windows, but there's only one window in this system right now. It's supposed to close at 50 degrees and open when it's 80 degrees. Now I've got it so the system I asked it for the instant variable T now, which is what temperature it thinks it is now, which is 99 degrees, because that's what I told it. And then I asked them what it thinks is the maximum temperature at which it should open, which it thinks is 80 degrees, which is good. That's what I told it. And then I asked it where it thinks the actuator leg is at, and it thinks it's at 0, implying that the actuator leg is fully retracted and the window was fully shut. And that's good because that's the default setting, and I haven't messed with that setting yet in this shell, so that's what it's supposed to say. So this one, tempbird takes in an XML, the root element of an XML, and does the light things I just saw in the red diode. Now XML temp is the root element of an XML file that is based on this string. I might have already said that in this video. And well, you know what it says. So XML temp is that thing. So I use it as a parameter in that. And that caused the light to turn on for about a minute. Now, you just saw that work. You know it works, and you have not done anything to it. Now, I'm now going to show you, let's see. I'm now asking the window object where it thinks, how far it thinks the thing is now. And it thinks that it has extended 295 millimeters. Because the thing is about 300 millimeters long, but I don't honestly want it to extend all the way. It's not necessary. It's not really good. But so that's the default maximum it thinks. So it's saying that it just extended all the way out, and it's as far as it's supposed to go now, 295 millimeters. So what that represents, the red diode represents the signal for the thing to come on, for the thing to go forward. The yellow diode in this situation represents the signal for the reverse pin. Now, but I'm going to tell it to go forward again. Keep in mind that it's already supposedly extended out all the way. And I've not messed with this XML file either. I'm going to type in the exact same command, but I don't expect the same exact thing to happen. I'll tell why in a minute. But first, let's see if what happens is what I think is going to happen. Okay, House.tempbird, XML temp. Okay, that part is cursor. I'm going to hover the camera over the lights while my hand hovers over the enter, and enter. And look how nothing happened, neither of the lights came on. That is because the system thinks that it's out all the way. I know it thinks this because I asked it how far you think that actuator is extended, and it said 295 millimeters, because that's what's programmed to think in that situation. So there's that. So that didn't work. Now I'm gonna try it again, and I want you to, this time I'm only gonna film the screen. The same thing is gonna happen, which is to say nothing in the diodes at least, but you'll see what the nothing that also happens on the screen. Well, that nothing happened on the screen because I forgot to put in the argument, but this nothing is going to be for a different reason. Alright, it's the correct argument, exact verbatim same command that I used a minute ago. Notice how it immediately went into the next line, didn't freeze or nothing. Because it's not supposed to go if the actuator is already where it's supposed to be. So it immediately returns to the next line, because remember how it kind of froze up while the signal was on? The fact that it didn't do that means that it thinks nothing happened, but no error message or anything popped up, so the thing went through. It just told it not to do anything, which is what it's supposed to do. So that's my demo for now for one of the bird commands. In my next video, I will demo some other commands.